right, last question, 26. What makes Sanjo's birdseed situation that we just talked about in 25 different from Gustavo's college fund situation? Why does doubling work for one situation but not the other? Consider this as you examine the two graphs. So here is Gustavo's stuff. So just right here. So this is Gustavo. I don't know if I'm spelling it right or not, but you'll get the idea. All right, so that was his money doubling, and this was the bird seed problem. So these are the graphs for that. And all right, let's start with the question. So part A, with your team, describe how each graph is the same. Well, each graph is the same where they're both, the graphs give us straight lines. If I look at the graphs, we notice that these go up by the same amount of units. This goes up by 1. These go up by 100, so their units are good. These go up by 1. These go up by 20. Let's see. What makes each graph different? The main difference I see is that this one starts already up here in the graph, like at 400, where this graph starts at 0. So how are they the same? They both have straight lines. How are they different? This one starts up already. This one starts at 0. Part B, how do the difference explain why doubling works in one situation and not in the other? Generalize why doubling works in one situation but not in the other. So remember, this is the one where the doubling worked for the situation, where we doubled the pounds, which doubled our amount of money. So this one is the one that was good. And if I look, notice how it is a straight line, but also notice how this starts at 0, 0. All right. And then from there, I doubled the price. And because I'm doubling the same amount every time, then what happens is I get this nice straight line because every pound I'm going up by the same amount. All right. But notice how this one starts at 0, 0. So this one is what they're going to do. They're going to call this a proportional relationship, which you're going to hear this word a lot in the next couple of weeks. So proportional. And I may be spelling it right, maybe not. Sorry about the bad handwriting. So this is proportional. And you can always tell when a graph is proportional by two things. It starts at 0, 0, and it's a straight line. All right, so when I look at this, I know this is proportional, which means it goes up by the same amount every time. And if I double the amount of seeds, I'll double the price. Now, this one is not proportional. So remember the two things over here. Had to be a straight line and start at 0, 0. Well, this one has a straight line, but the graph doesn't start at 0, 0. So this one is going to be not proportional because of the two things we talked about. Proportional. All right, it has to start at 0, 0, and it has to be a straight line. This graph doesn't start at 0, 0. All right, it is a straight line. All right, but this is not proportional. And this is why Gustavo couldn't double his years and then double his amount of money because it didn't start at 0, 0. All right, let's see what else do we have to do. So that was B. So part C, the pattern of growth in Sanjo's example, that's this one right here, is an example of a proportional relationship. In a proportional relationship, if one quantity is multiplied by a scale factor and the other is scaled by the same amount, Gustavo's bank account is not proportional because it grows differently when the number of years double, the balance doesn't double. Work with your team to list the characteristics. So we already did that. All right. So this idea, I should be able to look at a graph and within 5 seconds see if it's proportional or not. It has to start at 0, 0, and it must be a straight line. All right, so that's the main thing that you need to take out of question 66. Proportional relationships when they're graphed is that they are a straight line, which means they're going up at a constant rate and starts at 0, 0.